We're going to look at 8.2, the algebra of functions and inverse functions. And let's start with composition of functions. So let's say we have two functions, f of x and g of x. And the composition of functions basically means you're going to plug one function into another function. And you can see it written as f of g of x. You just have to be careful when that's a circle. It does not mean multiplication. That means of. And when I see it written like this, a lot of times I convert it, make that open circle into a parentheses to show the composition as f of g of x. So basically what this composition is saying is take this function g and plug it into your function f. So let's look at an example. We have f of x equals 3x minus 2 and g of x equals 4x plus 1. Find f of g of x. So kind of work from the inside out. So I'm going to start with the inside. It says g of x. So this is saying go to the function f and plug in g of x wherever you see an x. So go to the function f, plug in g of x where you see x. Before I do that, I'm going to rewrite this and say this is f of g of x, which is 4x plus 1. So I'm just replacing g of x with what g of x equals, which is 4x plus 1. Now if I read this, this is saying f of 4x plus 1. So I'm going to go to the function f, and instead of plugging in x, they want me to plug in 4x plus 1. So I'm going to have 3 times 4x plus 1 minus 2. And now we just simplify. So let's distribute the 3 through the parentheses and get 12x plus 3. And then bring down the minus 2. And last step, just combine your 3 minus 2 to get 1. Okay. Just do the same thing again. We're going to do g of f of x, so the other way around. So again, I'm going to start with the inside parentheses. It says f of x, so I'm going to rewrite this as g of, and I'm going to plug in what f of x is, which is 3x minus 2. And now this is saying g of 3x minus 2. That means go to the function g, and then replace this x with 3x minus 2. So I'm going to write 4 times, instead of an x, I'm going to write 3x minus 2, and then plus 1. Go ahead and simplify. We get 12x minus 8 plus 1. Combine the negative 8 plus 1, you get 12x minus 7. Okay, the next one says find f of g of 2. And for f of g of 2, instead of just plugging in a variable, we're actually going to be getting a number. So we could start from the very beginning, but since we already found f of g of x, I'll just write that down here. So remember, we found f of g of x, and that equaled 12x plus 1. So f of g of 2 basically says take this function, but instead of x, I want to plug in 2. So I'm going to go to where I see this x right here, and instead of x, we're going to write 12 times 2 plus 1. Go ahead and simplify. 24 plus 1 is 25. Okay, so now we have f of x equals 2x and g of x equals 3x plus 5. Find g of f of x. So we're going to write the g. Again, I'm going to replace f of x with what it is equals, which is 2x. So now I'm trying to find g of 2 of x. So this says go to the function g, and where I see this x, plug in 2x. So I'm going to go to the function g, and I'm going to say 3 times, instead of x, I'm supposed to plug in 2x plus 5. Now simplify. This is 6x plus 5. Okay, let's look at an example where we're going to use this composition of functions. It says the number of bacteria in a refrigerated food is given by n of t equals 20t squared minus 80t plus 500, where t is the temperature of the food in degrees Celsius. When the food is removed from refrigeration, the temperature of the food is given by T of H equals 4H plus 2, where T is the time in hours. Find the composition and interpret its meaning. So first thing, let's find the composition, N of T of H. So I'm going to write N of, and then T of H is 4H plus 2. So now I'm going to go to the function N, and wherever I see that t, I have to put 4h plus 2. So 20 times 4h plus 2 squared minus 80 times 4h plus 2 plus 500. Okay, before we can simplify, remember if you have 4h plus 2 squared like this, you have to FOIL this. This is 4h plus 2 times itself. So this is going to be 20 times, and I'm going to go ahead and FOIL the first terms, 4h times 4h, 16h squared. Outside and inside terms, so if I was multiplying this by itself, I'd have 8h plus 8h, which is 16h. And you can write this out if you want. I'm just kind of doing it in my head. And then for my last terms, I'd have 2 times 2, which is 4. Minus, I'm going to distribute the negative 80 through my parentheses, and I get negative 320h minus 160, and then don't forget that plus 500. Okay, now I'm going to distribute the 20 through the parentheses, and I get 320h squared plus 320h plus 80 minus 320h. I'll just leave these right now, minus 160 plus 500. I'll combine them in the next line. Okay, so now we're going to simplify. Let's combine like terms. First, just bring down the 320h squared. Then the 320h is cancel. One's positive and one's negative. And you have 80 minus 160 plus 500, which combines to be 420. So n of t of h equals 320h squared plus 420. Then it says interpret its meaning. Basically, what this means, n is the number of bacteria, and h is the time in hours. So this formula right here tells us the number of bacteria that's in the food after h hours. So now I wouldn't have to first find the temperature based on the hours and then plug in the temperature to find the number of bacteria. I can just plug in directly the hours and find the number of bacteria. So it makes it a little bit simpler. It's a one-step process versus a two-step. Okay, so B says find the time when the bacteria count reaches 2,000. So in this case, I'm actually given the bacteria and I want to know the time. So I'm plugging in 2,000 and I'm solving this equation, 320h squared plus 420. Subtract 420 from both sides and you get, I'll go ahead and show that. So subtract 420. I'm actually going to come up here. And you get 1580 equals 320h squared. Divide both sides by 320 to get h squared by itself. And you get 4.1 9375 equals h squared. I try not to round to the end. It's supposed to be an h squared. Okay. And now to get h by itself and not have the squared, you take the square root of both sides. And I only need the positive answer. We don't have a negative number of hours. So when you take the square root, you're going to get approximately 2.2 hours. Okay, so let's look now at the next slide. Oops, did I go? Hold on 1 second, I think I went too far. Yeah. Okay, down here. One-to-one function. So now we're going to talk about what is a one-to-one function. So last time we talked about what a function was, and you can look over all those notes. Remember we did the vertical line test, no x values repeat. A one-to-one function means not only do the x values not repeat, but no y values repeat. So remember, it's already a function, or it has all the rules of a function, but in addition, no y values repeat. And the way to see if a graph is a one-to-one function is to use the horizontal line test. So for functions, we had the vertical line test. For one-to-one functions, we have the horizontal line test. And so I'm going to draw a couple of functions. So we saw these last time. We have the parabola and a straight line. I'll just do these two. And the horizontal lines test says draw a horizontal line across your graph. And if it hits more than once, which in this case is it does, then this is not one-to-one. That means that it has y values that repeat. So if this happened to be y is 5, you also have y is 5 over here. So it's not one-to-one. With this straight line, if I draw a line across, a horizontal line, it only hits once. So this linear function is one-to-one. No y values repeat. Okay, so why are one-to-one functions important? One reason is that if you're one-to-one, then your inverse, which we're going to talk about in a minute, is a function. Okay, so what is the inverse first before we find the inverse of a function? There you go. So in inverse, let me just write an example over here in the corner, would be converting from degrees Fahrenheit to degrees Celsius and vice versa. So the one is F equals 9/5 C C plus 32. So that converts from degrees Celsius to degrees Fahrenheit. Let's do the other way around. Degrees Celsius equals 5/9 times F minus 32. Okay, these are inverse functions. They basically are the reverse of each other. So this is degrees Celsius to Fahrenheit. This is degree Fahrenheit to Celsius. We're going to look at basic functions, f of x, g of x, but these are two applied examples. Okay. So when we're solving for g of x equals square root of 3x minus 5, and I say I want to find the inverse, I'm going to write the steps down here, and then we're going to go ahead and find the inverse on the other side. Let me clear this. Okay, so step one, the first thing that you want to do when you're finding the inverse of a function is, instead of writing, and I'm going to put this in quotes, f of x, because it could be f of x, it could be g of x, it could be h of x, whatever you have for your function. In our case, we have g of x. Replace it for y. I'm sorry, I want to write that actually the other way. I said that backwards. So we want to replace y for f of x. The way this is written, we have to switch this so it makes sense. So let me erase this and fix it. Okay, so substitute y for f of x or g of x or whatever you have. Okay, the other way around, instead of f of x, write y, is basically what you're doing. So I'm going to write y equals the square root of 3x minus 5. Okay, once you've done that, since I don't have an actual equation here with c and f, I find it easier just to say switch x and y. So that means where you see an x, put a y, where you see a y, put an x. So I'm going to go ahead and do that. I have y here, so I'm going to put an x instead, equals the square root of 3y minus 5. Be careful that minus 5 is not inside the radical sign. Okay, once you do that, and the reason I do this is for this third step, is now you want to solve for y. So the goal is to get y by itself. So you just have to use all the algebra you've learned. In this case, I need to add 5 over to the other side first. Okay, and now in order to get y by itself, I have to get rid of that square root sign. So to get rid of a square root sign, I'm going to square both sides. The square root and the squared cancel each other out. Remember, basically these cancel each other out. And I'm going to write the 3y first equals x plus 5 squared. And then the last step is to divide both sides by 3. So I get y equals x plus 5 squared divided by 3. Now, if there's something added or subtracted to this x plus 5 squared, I might need to FOIL this out and then combine like terms. But I don't have anything added or subtracted, so I'm just going to leave it the way it is. Okay, and then the last step is I want to show this is the inverse. So instead of writing y equals, the way that you write inverse is f, it looks like to the -1, but this means f inverse of x. And I'm going to put this in quotes again because it just depends on what original letter you started with. Did you have f of x, g of x? Whatever it is, write it as an inverse instead of y. So since we had g, I'm going to write g inverse of x equals x plus 5 squared divided by 3. So this shows that this equation is the inverse of g. Okay, so let's practice with another example. This says find the inverse of h of x equals 2x cubed plus 3. So we're just going to go through those steps, those 4 steps again. So the first thing I'm going to do is, instead of h of x, I'm going to write y equals 2x cubed plus 3. Okay, let's go ahead and switch our x and our y's. So I have x equals 2y cubed plus 3. And now we're going to solve for y. So I'm going to subtract 3 from both sides. 3. And I have x minus 3 equals 2y cubed. And now I'm going to divide both sides by 2. And you get y cubed equals x minus 3 divided by 2. And the last step is we want to get y by itself. So instead of y cubed, I just want to have y. So the opposite of y cubed, or what's going to help cancel that out, is taking the cubed root of both sides. That's what that little 3, that index of 3 is. So I now have y equals the cubed root of x minus 3 divided by 2. And then remember, just to show that I have the inverse, I'm going to, instead of write y, I'm going to write h inverse of x equals the cubed root of x minus 3 divided by 2. Okay, to prove whether two functions are inverses of each other or not, that you can take the composition. So if they're inverses, if you take the composition of f of g of x, that should simplify to just be x. And so it has to go in both directions. If you take g of f of x, that should just simplify to be x. Okay, so if I want to prove whether f of x equals 5x minus 10 and g of x equals 2x cubed plus 3 are inverses, I'm going to take the composition, and this is a good practice of composition of functions. So f of g of x, so first thing I'm going to do is plug in g of x, which is 2x cubed plus 3. And now I'm going to go to the function f, and instead of an x, I'm going to plug in 2x cubed plus 3. So 5 times 2x cubed plus 3, then minus 10. So let's simplify, distribute the 5, 10x cubed plus 15 minus 10. And I can see here that there's no way this is going to simplify to just be x. This is 10x cubed plus 5. So I don't even need to do the other direction because this is not x. So these are not inverses of each other. If one direction doesn't work, then you can just stop because it has to work in both directions. So they're not inverses of each other. Okay, let's talk about the graphs of inverse functions. So when you have inverse functions, they're the reverse of each other. And we'll talk about the domain and range of these functions after we graph them. So the graph of inverse functions are actually reflections about the line y equals x. So here we have 2 to the x power. Okay, and let's just write the domain. The domain here is negative infinity to infinity, that there's no gaps or stops in this graph. You can have any x values. That's supposed to be an infinity sign there. And then the range, starting down here at negative infinity on the y-axis and moving up, you can see that the y values start right after 0 and go on to infinity. So this would be, the range is, oops, sorry, not including 0, because 2 to any power can never equal 0. So this is 0, but not including 0 to infinity. Okay, so that's our domain and range. Let's graph the line y equals x. It basically means if x is 1, y is 1, x is 2, y is 2, etc., right? And if x is negative 1, y is negative 1. So basically it breaks the first and the third quadrant directly in half. Let's see if I have a line tool here. Here we go. Okay, so there's our line. And you need to take this graph now and reflect it about the line y equals x that we just drew there. And the best way to do it sometimes is to fold your paper along this green line and kind of get an idea of where that line is going to wind up. So think of if kindergarten, when you're making those butterflies and you paint half the side of the paper and then you fold it and you get the other half on the other side. That's kind of what's supposed to happen here. And to help you, let's just label this one point here. This is the point 0, 1. Okay. And the inverse is the reverse of that. So the inverse, instead of having the point 0, 1, would have the point 1, 0, which is right here. Let's see, I'll put it down here. Okay. So it kind of gives me an idea where it's going to hit the x-axis. And then I'm going to do my best to sketch this. I'm not doing every point right now, so it's going to be a rough sketch. And on the homework, you'll be looking just to pick out the graph that's the inverse. You won't actually be sketching it. So it's going to go down like this and then come down and not cross the y-axis. Like this one doesn't cross the x-axis. This doesn't cross the y. So that's the general idea of what this graph. Mine's not really smooth. Okay, so if we look at this graph, let's find the domain and range of this graph. So the domain would be the x values, and if I start over here at negative infinity go, you can see my x values start right after 0 and then go on. So my domain is 0 to infinity. And then my range, my y values start at negative infinity and they go on forever, no gaps. So my range is negative infinity to infinity. So notice with the inverses, your domain and range have flipped. So these are reverses of each other, which means the points reverse, and also your domain and ranges flip.